Bismillahirrahmanirrahim. In the name of Allah, the most gracious, the most merciful. Assalamu alaikum. Today we will study about rocket. A rocket has a payload, a guidance system, propulsion system, combustion chamber and fins. A multi-stage rocket or step rocket is a launch vehicle that uses two or more rocket stages, each of which contain its own engine and propellant. At liftoff, the first stage is responsible for accelerating the vehicle. At some point, the second stage detaches from the first stage and continues to orbit under its own power. The second stage is programmed to shut itself off once the rocket and spacecraft are in orbit. As the propellant is burned and expended, the structural dead weight of empty tankage is discarded, thus making the entire rocket more efficient. Thus, the main advantage of multi-stage rocket is to reduce its total weight as it moves beyond space. A payload is a term used to describe the portion of a spacecraft that is responsible for achieving mission's primary objective. It could be a satellite or a spacecraft carrying human. The guidance system of a rocket includes very sophisticated sensors, onboard computers, radars, and communication equipment. The guidance system has two main roles during the launch of the rocket: to provide stability for the rocket and to control the rocket. There are three types of chemical rocket engines. Number 1 is solid propellant, number 2 is liquid propellant, and number 3 is hybrid propellant. Let's consider number 1, that is solid propellant. In a solid fuel engine, the fuel and oxidizers are already mixed together and set as a solid in the combustion chamber. The solid is called propellant grain. A hole through a cylinder serves as a combustion chamber. When the mixture is ignited, combustion takes place on the surface of the propellant. One example of combustion reaction is that potassium nitrate is oxidizer, sulfur and carbon are the fuel. Potassium nitrate plus sulfur plus carbon give us potassium sulfide, nitrogen gas, carbon dioxide, and a lot of heat. The combustion produces great amount of exhaust gas at high temperature and pressure. The hot exhaust is passed through the nozzle, which accelerates the flow. Thrust is produced according to Newton's third law of motion. His law states for every action there is an equal and opposite reaction. The engine produces hot exhaust gases which flow out of the back of the engine. In reaction, a thrust is produced in opposite direction. Solid propellant are much easier to store and handle than liquid propellant rocket. High propellant density makes for compact size as well. The disadvantage is the motor cannot be controlled once ignited, and the specific impulse is rather low because of low chemical energy of solid propellant. Let's consider the second propulsion system, that is liquid propellant. It consists of fuel chamber, oxidizer chamber, combustion chamber and nozzle. The fuel can be kerosene, alcohol, hydrazine, liquid hydrogen. Oxidizer can be nitric acid, nitrogen tetroxide, liquid oxygen, liquid fluorine. One reaction is the screen reaction, that is hydrogen plus oxygen gives us water. Liquid oxygen and liquid hydrogen are pumped into the combustion chamber of the engine. When the propellant is ignited, the hydrogen reacts explosively with oxygen to form water. This reaction produces large amount of energy and steam. The advantages are higher specific impulse, thrust can be throttled, magnitude of thrust can be controlled, engine can be shut down and restarted. The engine can be throttled by varying the rate of liquid injected and stopped and started by cutting the fluid flow and later restarting it. The disadvantages: need of pumps, piping and separate storage. That means rocket is more massive. The third type of propellant system is hybrid propellant. The hybrid propellant engine is an engine that combines advantages of both solid and liquid propellant. Hybrid propellant provides safety, reliability, and environment-friendly manufacturing compared to others. A hybrid propellant is a rocket with a rocket motor that uses propellant in two different states of matter, one solid and other either liquid or gas. Let's study the motion of a single-stage rocket. The first part of the velocity time graph shows that the fuel is being used up and the rocket is accelerating in the upward direction. The second part of the velocity time graph shows that the fuel has run out and the rocket is now decelerating. The third part shows that the velocity is negative, which means that the rocket has changed the direction and is now moving downwards. The fourth part shows that the terminal velocity is reached, that is the maximum velocity, and at this point the acceleration is 0. Let's study the acceleration time graph of a single-stage rocket. The first part of the graph shows that the acceleration is positive because the rocket is using up the fuel and is accelerating upwards. The second part of the graph shows that the acceleration is negative because the rocket has used up all its fuel. The third part of the graph shows that the rocket has changed direction. The fourth part of the graph shows that the terminal velocity is reached, that is, acceleration is now 0. Let's study the motion of a two-stage rocket. The first part of the velocity time graph shows first stage of rocket is being burned. The second part of the velocity time graph shows that the second stage of rocket is being burned. In our case, the acceleration of the first stage of rocket is greater than the acceleration of the second stage of rocket. The third part of the velocity time graph shows that the rocket is decelerating, the fuel has run out. The fourth part shows that the rocket has now changed direction and is now moving downward. The fifth part of the velocity time graph shows that the terminal velocity is reached. Let's study the acceleration time graph of a two-stage rocket. When the fuel is being burned in the first stage, the rocket is accelerating upwards. When the fuel is being burned in second stage, the rocket is still moving upward. However, the acceleration of the first stage is greater than the acceleration of the second stage in the case that we are considering right now. When the fuel has burned out, the rocket starts to decelerate, that is the third part of the acceleration time graph. During the fourth part, the rocket has changed direction and is now moving downwards. During the fifth part, terminal velocity is reached, that is acceleration is 0 and the velocity is constant. Let's consider a simple case of Newton's third law of motion, that is for every action there is an equal and opposite reaction. If we untie a balloon pushes the air down and the air pushes the balloon up. This is a simple example of action and reaction, and this is the principle used in rocket. The mass of rocket is capital M, the mass of fuel is delta M. After delta T, rocket ejects delta M, that is fuel is being burned and is ejected. Hence, after delta T, only the rocket mass that remains is capital M. The rocket velocity increases by delta V, hence after delta T, rocket's velocity is V plus delta V. Delta V is the change in the speed of the rocket. Fuel is ejected with speed VE. VE is the exhaust speed. The system of ejected fuel and rocket is isolated. Therefore, change in momentum delta P is equal to 0. Final momentum minus initial momentum is equal to 0, which means initial momentum is equal to final momentum. Initial momentum is equal to mass of rocket plus mass of fuel times the initial velocity, capital M plus delta M times V, which was the initial velocity. Final momentum is equal to mass of rocket times V plus delta V, where V is the initial velocity and delta V is the increase in the velocity of the rocket, plus delta M, which is the mass of the fuel, times V minus VE, where V is the initial velocity and VE is the exhaust velocity. If we equate initial momentum is equal to final momentum, initial momentum is equal to capital M, that is the mass of rocket, plus delta M, which is the mass of the fuel, times V, which is the initial velocity, is equal to final momentum, that is capital M, that is the mass of the rocket, times V plus delta V, where V is the initial velocity and delta V is increase in the rocket velocity, plus delta M, which is the mass of the fuel, times v minus ve, that is v is the initial velocity and ve is the exhaust velocity. If we open the bracket, we see a lot of terms cancelled out and we are left with capital M delta V is equal to delta M times VE. Capital M is the mass of rocket, delta V is the increase in the rocket speed, delta M is the change in the fuel mass, and VE is the exhaust velocity. As delta T approaches 0, delta V approaches dV, delta M approaches dm. Therefore, capital M times dV is equal to VE times dm. Capital M is the mass of the rocket, dV is the change in the velocity of the rocket, VE is the exhaust velocity, and dm is the change in the mass of the fuel. Increase in exhaust mass is equal to decrease in rocket mass. If we rearrange the equations and integrate on both sides and put in the limits, the final result that we get is Vf minus Vi is equal to Ve ln Mi over Mf. Vf is the final velocity, Vi is the initial velocity, Ve is the exhaust velocity, Mi is the initial mass of the rocket, and Mf is the final mass of the rocket. The increase in rocket speed is proportional to exhaust speed VE of ejected gases. We know capital M, that is the mass of the rocket, times dV, that is the change in the velocity of the rocket, is equal to dm, that is the change in the mass of the rocket fuel, times VE, that is the exhaust velocity. Increase in the mass of the fuel is equal to decrease in the mass of the rocket. Capital M dV is equal to magnitude of VE dm, where dm is the change in the mass of the rocket. M dV over dt is equal to magnitude of VE dm over dt. Thrust is equal to force, force is equal to ma, a is the acceleration, acceleration is equal to dv over dt. Therefore, thrust is equal to capital M dv over dt, which is equal to magnitude of VE dm over dt. Thrust increases as exhaust speed increases and rate of change of mass increases. May Allah bless us all. Thank you for watching. Allah Hafiz.